All right, so here's our next one. Now, there are some formulas that you're going to have to know for these. Like we had to know the area of the circle was pi r squared. Total guessed right. Volume of a sphere?
No idea.
No idea. So that some of them will be there. If I put some of the more common formulas that you'll need to know, like volume of sphere, you'll just have to know those ones. If I put something complicated on there, like maybe a little bit more complicated, like the volume of a cone, something a little bit more complicated, then I'll give you the formula in the question. But some of them, like area of a circle, you'll need to know those.
Isn't it volume of a cone pi r squared times base or height?
Close? That would be a cylinder. And a cone is just a third of a cylinder.
So then what we
Pi r, yeah, divide by 3. Okay, but here we have a balloon 30 centimeters in diameter and is being inflated such that its radius increases at 3 centimeters per second. So again, that is telling us that radius is a function of time, and we know dr dt is equal to 3 centimeters per second. So one of the things that we're going to have to find out is what are we changing, and usually it's our rate of change is respect to time. And so that means that our radius is a function of time because it changes depending on what time it is. How fast is the surface area? So yeah, we don't need volume for this one. We're going to need surface area of a sphere. How fast is the surface area? So we know surface area, I'll call it S, is a function of time. And we want to find ds dt. So what you have to know is how is surface area related to the radius? Does anyone know surface area of a sphere?
No.
Of a sphere, like a golf ball.
4r squared.
Close. 4 pi r squared. If you think of a circle or a sphere, if you look at it from one side, it makes a circle. If you look at it from the back side, you get another circle. That would be 2 circles, right? But that would be a flat disk. You'd have to look at it from the top, and then from the top, oh, it's another circle. And from the bottom, another circle, and that would be 4 circles. Oh.
Is that a TaylorMade?
It is a Tommy Armour golf ball.
Tommy Love?
No, this is Winnipeg Jets golf ball. Yeah. No, they're used quite a bit more than Detroit Red Wing golf balls because the Jets never make the playoffs. So. Okay, so there's our formula. Could we take the derivative with respect to t of both sides and use implicit differentiation? So I'm going to take the derivative with respect to t of both sides since s is a function of t. This will just become, well, the derivative is 1, and then you'd have ds dt. On this side, you would have 8 pi r for the derivative of that, and then the chain rule, the derivative of r is dr dt.
Why is it? Oh,
What are we trying to find? We're trying to find ds dt. It's already by itself. Do we have all the other information?
no.
Caitlin says no. Now she says, oh yeah. At what radius do we want to find the surface area? We go back to our question. At 30 centimeter in diameter, so 15 in radius. And it's already changing at 3 centimeters per second. Multiply all that out, and ds dt, as an exact answer, we'd have 24 times 15, which is what, 360? 360 pi.
24 times 360?
No, 24 times 15.
Okay.
Is that 360?
Oh, geez,
Yes, it is.
All right, we got it right. I'm glad we have fast calculations and calculators to use.
1,130.97335529.
So 1,131.
Thank you. And since we're dealing in centimeters, this would be centimeters
Cube.
squared. We're dealing with surface area. Centimeters squared per second. And that is how fast it's increasing at that time. So if you waited 1 second more, you could imagine that much more surface area being created. And then eventually it would pop. Very fun.